Hi children, here I am with your favorite topic, projectile motion. You all must be waiting for this topic to start. In coming 2 sessions, I will elaborate all the things which is related to the topic so that you can solve a question if it comes from the topic. And this is very important from examination point of view also. Every year you get at least 1 or 2 questions based on this topic. तो शुरू करें? Here comes your favorite topic, projectile motion. What is projectile motion? When an object is thrown obliquely in vertical plane, the path is parabolic and the motion is projectile, which is written here. Now what happens when an object is thrown obliquely in a vertical plane? Since it is thrown in vertical plane, so its motion is governed mainly by gravity and effect of air resistance. But here for simplicity, we will neglect the effect of air resistance and will consider gravity only. That also, gravity has to be constant throughout the motion. So then this becomes very simplified version of a projectile motion, which we are going to consider. So let us draw the situation here. From this point, an object is thrown. Let initial velocity u at some projection angle theta to horizontal. So it will move in this kind of parabolic path and will reach to the ground at some distance in same horizontal level. Of course, g is same throughout the motion we are considering. Now this motion can be analyzed very easily if we analyze it separately in x and y direction. So now onwards I am going to consider horizontal direction as x direction and vertical direction as y direction throughout this session. Now we can write that in x direction initial velocity has component u cos theta and in y direction it has component u sin theta. If we analyze both the motions separately, what kind of motion it will be? If we write for horizontal, then in horizontal direction or in x direction, because acceleration due to gravity is working only in vertical direction. So throughout the motion, there will be no change in horizontal component of velocity. What does it mean? That in horizontal direction, it behaves like a uniform motion. And what about y direction? That is vertical direction. In vertical direction, as we know, acceleration due to gravity is there. So, and the value we are taking as constant throughout the motion, value of g is taken constant. So, it can be treated as a uniformly accelerated motion. This is uniformly accelerated motion. Let us first start with the term. This is the terminology used in projectile motion. The first term is time of flight. Now what is time of flight? Time of flight is the whole time a projectile takes to complete its journey. Do remember, whatever we are deriving here, that is for a standard projectile motion. It has to be strictly from the same horizontal level to the same horizontal level. If these levels are disturbed, if initial level is somewhat higher than or lower than the final level, then of course equation has to be written separately. Directly we cannot use the formula derived here. So here we are deriving for a standard kind of horizontal motion where initial and final positions are along a same horizontal level. This is initial velocity u and angle of projection is theta. Now for the whole journey, if we consider displacement along y direction, see it had started from P and has reached to Q. So for this displacement P to Q, what is the vertical displacement associated? Is there any displacement in vertical direction in final journey? No, there is no vertical displacement for the whole journey. So we can write delta y to be 0. Now for delta y, since it is a uniformly accelerated motion, this can be written as ut plus half at square, which is here uyt plus half ayt square. This t I have considered as time of flight. This is the time taken for whole the journey. Now what is uy? Uy is vertical component of initial velocity, which is u sin theta. So this is u sin theta t. Ay is minus g, so minus half g t square. and this value is equal to 0. Now we got value of t, that is equal to 2u sin theta upon g. So this is the time of flight for a standard kind of projectile motion, where the motion has started from a level and has landed again to the same horizontal level. The other terminology which we are going to use is horizontal range. Now what is horizontal range? If particle is thrown from P and has landed at point Q, then horizontal distance between P and Q is known as horizontal range. Again, this is for a standard kind of projectile motion. All the derivations are for this kind of standard motion only. Otherwise, we have to write separately equations in x and y axis. Now here, this range we have to calculate. What will be its value? As we know that in x direction motion is uniform, there is no acceleration involved. So if acceleration is not there, velocity component along horizontal will remain the same, and which is equal to u cos theta. So if we multiply this with time of flight, we will get horizontal range. And what is time of flight? Just now we had derived, that is u cos theta into 2u sin theta upon g, or on solving it can be written as u square 2 sin theta cos theta, which can be written as sin 2 theta upon g. So this is the range for a standard projectile motion. The next terminology is maximum height. What is the maximum height reached? Because as we see in a projectile motion, the motion starts from here and its height continuously changes. Then it reaches the top, which is the maximum height. After that again it comes down, lands up on the same plane. So this h we have to derive now. As we know, at maximum height, vertical component of velocity becomes 0. So Vy can be written as 0 for the maximum height. Now if we use formula, Vy square is equal to Uy square plus 2 Ay delta y. So what is Vy square for maximum height? That would be 0 is equal to Uy, as you know, this is u, this is theta. So Uy can be written as u square sin square theta minus 2g, and delta y is h for the maximum height. From here we can write h as u square sin square theta upon 2g. Directly we can use this formula whenever required, but it should be for a standard projectile motion. The next thing is equation of trajectory. What is equation of trajectory? Equation of trajectory is actually a path equation. The path a projectile follows, if we write its mathematical equation, that is known as equation of trajectory. So let us see how this can be derived. Again I am writing along the x-axis and along the y-axis separately. So if we write equation of motion for displacement along x and y-axis, that would give, for x-axis it can be written as u cos theta into t. Here t is any arbitrary time and x is position corresponding to that arbitrary time. So x can be written as u cos theta t, as there is no acceleration involved in x direction. For y we have to write u sin theta t minus half gt square. Now for equation of trajectory, relation has to be set between y and x coordinate. This is how equation of trajectory or path equation is written. So this is the undesired physical quantity involved here, which we have to eliminate to get equation of trajectory. So let us now substitute value of t from equation 1 to equation 2. T can be written as x upon u cos theta. If we substitute here, this will come u sin theta into x upon u cos theta minus g by 2 and square of t, which is x square upon u square cos square theta. These two got cancelled, which is x tan theta minus g x square by 2 u square sec square theta. So this is how equation of trajectory is obtained. Now if in a question at any moment of time x coordinate is given there, we can calculate directly with the help of this formula the y coordinate and vice versa. The equation of trajectory can also be written as, if you take this x tan theta as common, this will come out 1 minus gx sec square theta, as I have taken 1x outside the bracket, and that is 2u square in denominator. One more tan theta has to be put here because I have taken tan theta as common. Now it can be written as x tan theta 1 minus, if x is only taken here, then it will be 2u square. Now this is sin theta upon cos theta, and sec square theta also is cos square theta here in denominator. So that will give sin theta into cos theta upon g. Can you recognize this term? 2u square sin theta cos theta by g, that is equal to range. So it can be written as x tan theta 1 minus x by r. This is very important result. Sometimes in a numerical, if directly range is provided, so with help of this equation we can determine the y coordinate when x is given and vice versa. So do remember this also. Generally students remember this one, but the second one they do forget because it is not very frequently used. But when it comes in a question, it will be a very handy formula to use with. Now one illustration I have taken from the projectile motion. The initial speed of an arrow shot from a bow at an elevation of 30 degree. Initial speed is given 15 meter per second and elevation is 30 degree. It is asking for its velocity when it hits the ground. So again when it comes to this level, okay, so how we will solve this? Let us analyze the situation by writing equations both in x and y direction separately. That is the common trend. So if we write in x direction, Vx, as we know no acceleration is acting in x direction, Vx directly can be written as ux. That will give you 15 cos theta. It is equal to 15 root 3 by 2. Now what about y direction? For y direction we have to write Vy square is equal to uy square plus 2ay delta y, and it is asking for the termination point. So for that point delta y will be 0. There is no effective displacement in y direction. So we will get Vy square is equal to simply uy square, as this reduces to 0, and the value is 15 sin theta and square of this term. Now this will give Vy is equal to plus minus 15 sin 30 degree. Now one plus sign is there, one minus sign is there. So which one we should choose? It should be the minus one, because positive direction indicates that its vertical component is in upward direction. When it is landing the ground, its vertical direction has to be downward. So we have to consider the minus sign here. So Vy will be equal to minus 15 sin 30 degree, that is 1 by 2. Finally we got value of V, that is in x direction it has the positive component which is 15 root 3 by 2 in x direction. So I minus 15 by 2 j. This is velocity when it hits the ground back, and as you can see these 2 points are at the same horizontal. So x component will remain the same. Of course it will remain the same throughout the journey. And what about y component? Y component will have the same magnitude, only direction gets reversed, and this is true for all 2 points. If you consider any 2 point in this projectile motion, whether this is these 2 are the points or this point, and at same horizontal this point, or this point at same horizontal again this point. So at all the points whatever be value of Vy here, it would be the same in opposite direction, in vertically downward direction. So whatever is
vertical component of velocity at any point of journey on the latter half. On the second half at the same horizontal level, we will get the same speed in y direction, only direction gets reversed for vertical component. For x component there will be no change, it will be same throughout the motion. And we can analyze a lot more things with the help of this. Let us say someone is asking what will be change in momentum for this projectile motion. Now what is momentum? If it is asking for change in momentum, it has to be final momentum minus initial momentum. Now that can be written as, if m you take as common, then that will be v final minus v initial. If we write separately in x in y direction, then that has to be vx minus uxi plus Vy minus Uyj. So this is how change can be written. Now would there be any change in this x direction? No, because these two values are same. Vx and Ux has to be same. So there will be no change in momentum along x direction. The only change will be along vertical direction. Then that will be equal to Vy and Uy, as we know, they have the same magnitude, only direction is different, direction is opposite. So if we write this, if we subtract it, it will be minus 2u sin theta j. This is change in momentum, that is equal to minus 2mu sin theta j. A lot number of terms can be derived, can be analyzed with help of this kind of analysis, where we are analyzing the motion both separately in x and in y direction. It can be for any point, whether this point or at maximum height or any other point. In one session, in any of the previous session, I had taken one example in which I had calculated time taken when velocity vector becomes perpendicular to initial velocity vector. That time I had done the question with help of vector relation, and that can be done also with component form. So sometimes it is easy when we use the vector form, and some other time it will be easy when we use the component form. So depending on the situation, we will use the relation, either it can be a vectorial or a scalar one in projection form.
Now let us solve one more example. Time taken by the projectile to reach from A to B is t. Then the distance AB is equal to. As you can see, it is the case of projectile motion on an inclined plane. So to calculate the value of AB, first let us write what is component of projection velocity, that is u, in the horizontal direction. Here it is more convenient to write the equation along horizontal. So first I am writing horizontal component of initial velocity. Let's say this be u. So UH will be equal to, now what angle u is making with horizontal direction? That is 60 degree. So it will be u cos 60 degree, which is u by 2. Now in the time of flight with this horizontal velocity, what horizontal displacement the particle will be having? From the given diagram, it will be equal to AC. So we can write value of AC to be equal to UH multiplied with T, where T is the time of flight, time taken by the particle to reach from A to B. As there is no acceleration in horizontal direction, so no need to write the acceleration term. Simply it will be horizontal component of velocity multiplied with time. On substituting the value of EH, it will be equal to UT upon 2. From geometry now we can see that what is relation between AB and AC. If we write sec 30 degree, that will be equal to, it can be written as AB upon AC. So from here we can write value of AB, it will be equal to AC into sec 30 degree. But as AC is already calculated, its value is UT by 2. So on substituting this UT by 2, sec 30 degree will be 2 by root 3. These two got cancelled and the result is UT upon root 3, which is our option number A. as it is obvious that we could have solved this problem even by writing directly equation along AB. But do remember, if we have to write kinematical equation along AB, then while writing displacement, we have to consider acceleration component along this direction as well, because the acceleration is in vertical direction, so there will be an effective component along AB. While if we write the equation along horizontal, there will be no consideration of acceleration in the horizontal direction. So, in this particular case, it is more convenient to write the equation in AC. And do remember, while solving a problem that is based on projectile motion on an inclined plane, do write equations in direction that is convenient according to the situation given in that particular problem. And it will be then easier to solve. Also, it will take less time during your exam to solve a given problem.
One more very interesting situation is there in which different projectiles are drawn. Let this is one of the projectile, let this be, then one other projectile, B, one more, A. If it asks what things can be interpreted from this diagram, so we are going to analyze now each of the kinematical terms that is associated with this kind of projectile motions. So let us first compare their time of flights. What about the time of flights? What can be directly interpreted from the diagram is that height should be same. So we can write maximum height for A has to be equal to maximum height of B has to be equal to maximum height of C. As we know, formula of maximum height is u square sin square theta by 2g. So for A it can be written as this is equal to ub square sin square theta b upon 2g and equal to uc square sin square theta c upon 2g. From here we can write ua sin theta a is equal to ub sin theta b is equal to uc sin theta c. Now what is this term u sin theta? That is actually y component of initial velocity. So all the factors which depend on only initial velocity in y direction will be same for these projectiles A, B and C. Now let us see what terms are there which only depends on vertical component of initial velocity. Is that time? As we know, time is equal to 2u sin theta by g. So it depends only on the vertical component of velocity. That also has to be same. So from here we can interpret this also, that TA will be equal to TB will be equal to TC. As we can see that horizontal range is not same. It is directly shown here in graph. So from horizontal range we can conclude that range for C is greater than range of B is greater than range of A. Now what is range? Range is horizontal component of velocity into time of flight. And since time of flight is same, so from here we can conclude one more thing, that horizontal component of C has to be more than horizontal component of B is to be more than horizontal component of A. So from on seeing the graph itself, we can conclude a number of things. Their heights are same, their vertical component of velocities are same, their time of flights are same, but their range are in this order, and in x direction initial velocities are in this manner. Can anything more can be interpreted from this? Yes, one more thing is there, that instantaneous y coordinate of all particles will be same because their initial velocity is same. So after same time they will reach to the same height. So y component of velocity also will be same for all three. One more thing can be added here, which is YA is equal to YB is equal to YC. You have seen so many things we can interpret from a given graph. Now in next session we will move to projectile motion along an inclined plane and then solve some questions based on projectile motion, as this is very important topic, interesting also, and this is used throughout the session of physics. Whether it is in electricity, it can be used in magnetic field, it can be used. So in all the domain of physics, this can be used. So look forward to the next session. Goodbye.